Hello everyone, welcome back. And the subject is system software and compilers. And topic for today is Lex and Yacc and their particular functions. Lex is a program generator designed for lexical processing of characters, inputs, output stream. Anything from simple text search program that looks for pattern in its input-output file to a C compiler that transforms a program into optimized code in program with structure, input-output two tasks occurs over and over. The functions of Lex is as follows. Firstly, lexical analyzer creates a program lex.l in the Lex language. Then Lex compiler runs the lex.l program and produces a C program lex.yy.c. Finally, C compiler runs the lex.yy.c program and produces an object program a.out is lexical analyzer that transforms an input stream into a sequence of tokens. Lex file format. A Lex program is separated into three sections by percentage delimiters. The format of Lex source is as follows. It consists of three parts, that is definition part, rules part, and user subroutines part. All are separated by the percentage command. Definitions include declarations of constants, variables, and regular definitions. Rules define the statement of form P1, that is action 1, P2, that is action 2, and Pn, that is action, where PI describes the regular expression and action 1 describes the actions. What action the lexical analyzer should take when pattern PI matches a lexeme. User subroutines are auxiliary procedures needed by the actions. The subroutine can be loaded with the lexical analyzer and compiled separately. Yacc. The Yacc command converts a context-free grammar specification into a set of tables for a simple automaton that executes an LALR1 parsing algorithm. The grammar can be ambiguous, specified precedence rules are used to break ambiguities. Yacc uses shift reduce parsing methodology to parse the given input. The shift reduce parser is essentially a push down automaton. It consists of a finite state machine with a stack. The stack is used to hold terminal and or non terminal symbols. It consists of the input file, that is definition part. The definition part includes information about the tokens used in the syntax definition, percentage token number, percentage token id. Yacc automatically assigns numbers for tokens, but it can be overridden by percentage token number 625. Yacc also recognizes single characters as tokens. Therefore, assigned token number should no overlap ASCII codes. The definition part can include C code external to the definition of the parser and variable declarations within percentage and percentage in the first column. It can also include the specification of the starting symbol in the grammar. Okay, percentage start non-terminal input file rule part. The rules part contains grammar definition in a modified BNF form. Actions is C code in fluid braces and can be embedded inside translation schemes. Input file auxiliary routines part. The auxiliary routine part is only C code. It includes function definitions for every function needed in the rules part. It can also contains the main function definition. If the parser is going to be run as a program, the main function must call the function yyparse input file. If yylex is not defined in the auxiliary routine sections, then it should be included. Ash include lex.yy.c. Yacc input file generally finishes with .y. Output files. The output of Yacc file is a the output of Yacc is a file named y.tab.c. If it contains the main definition, it must be compiled to be executable. Otherwise, the code can be external function definition for the function int ypass. If called with the hyphen d option in the command line, Yacc produces as output a header file y.tab.h with all its specific definitions. Particularly important are token definitions to be included. For example, in a Lex input file, if called with the hyphen v option, Yacc produces as output a file.y output containing a textual description of a LALR parsing table used by the parser. This is useful for tracking down how the parser solves conflicts. Here is an example of a Lexan Yacc program, that is the squares of a number. At first, let me see with the Lex file and how it works. Basically, Lex part consists of the definition section, rule section, and the subroutine section. Here you can see that in the definition section in this text part, you are having hash include y.tab.h, which is the definition part in your program, and it is opened and closed by the flower braces, and this is the definition part in your lex program. And when we comes to the rules part, where for taking a particular program, you want to go through the particular rules which can be followed for implementing your program. In such cases, you have to follow the rules, like for example in this program you have 0 to 9 plus, like where here you can see like how the numbers were taken, like where operators are used and where identifiers are used for your program to execute and explain, where for returning the after executing all the identifiers and operators, where when you want to return back to your original end of line or something else, where you'll use the particular grammar called a slash n, which helps for returning to end of the line. And after this definition and rules, you have to use particular subroutines, which you are used for your program. Here the subroutine, you can see that it is specified with int yy trap, where at that particular term, your program will return back to 1. This is about the lex file. After the execution of the lex file in your SSCL, you want to go back to, and next you want to continue with the Yacc file. Here Yacc file, it consists of the definitions and rules part, and at last it consists it is included with the main function. Here Yacc function. Definition part is in definition part, it can include header files, variables, and for etc. In rule sections, for example, you can see patterns and actions will be included. Here in the definition part, it includes the header file called hash include stdio.h, where it is open and closed with the flat braces. When it's come to the what we can say, when we come to the rules part, here you have particular rules that can be followed. When you are going to give input for your particular program, you have to start with the input file, like line, which is line. Soon after that line as executed, you have to give the command as end of the line. Soon after that line is executed, your program will take your next line to the end of the line. Likewise, you have to continue with your program. After that, you have to declare the declarations, like for int num you are giving it as $1. This is the declaration, and int square you are giving a num star num. Then you, after doing all these things, you have to print your statement, like this program name is just to see the squares. So the line is the square of percentage d slash n is num comma square. And after completing the definition and rules, what this is the main function, where the output is dependent on this function. After giving the main function, you can expect the particular output respectively. Compile and generate the lexer and parser files using the following commands: lex square.l, yacc-d square.y, gcc lex.yy.c, y.tab.c -o. These were the commands which lex.square.l is a command which is used for the execution of the lex program. Yacc-d square.y is a command which is used for the execution of the Yacc program. And after executing both of the programs, when if your code is correct, you will get both of the commands, and you can enter the commands in your command prompt. Soon after entering all these commands, again you will come back to the next command where you have the option to merge both the commands to get the particular output respectively. At the time you want to give the command like gcc lex.yy.c, y.tab.c -o. After doing all these things, square underscore parser, now you can run the program and input a number to compute its square. After running the program, you can enter a number followed by a new line. The program will output the square of the entered number. Note, this program assumes that the input number is a non-negative integer. If you want to handle negative numbers or floating point numbers, you would need to modify the lexer and grammar accordingly. Thank you.